Hello students, welcome to my class. Today we are going to discuss few questions related to JEE Advanced pattern. Clear friend? So let's start with the topic. I think this is one of the important topic related to JEE Advanced examination. So because if you have strong knowledge related to D and F block element, then definitely it will help you in next chapter, that is coordination compound. Let's start. This is the question friend. This is completely a question from acid base titration, or you can say that is the titration. Simple question. Identify P and Q in the given reaction. Ki plus MnO4 minus H plus, that is in acidic medium. We people know in acidic medium what will happen, that is MnO4 minus will be converted to Mn2 plus ion, and Ki will be converted to I2. Look at the option. Here is Mn2 plus. Yes, sir. And this P is I2. Clear to you, friend? This is one of the simplest question related to the D and F block. It includes some part of D and F block. Why I have taken this question is very simple. That is Mn, involvement of Mn due to this reason. And same reaction you can study also in titration. Now the next one, that is the basic medium. As we know, in basic medium what will happen, friend? MnO4 minus will be converted to MnO2, and I minus will be converted to IO3 minus. Clear? So Q is MnO2 and P is I2. So in this case, tell me what is the option? I2 and MnO2. So for this question, it's very easy, friend. D is the correct option. I2 and MnO2 respectively. Now I'm going to wrap this part and we'll discuss the next one. Now let's move to the next question. Now check it out. The next question is test tube 1 KOH, excess no change, dilute H2SO4 no change, NH4OH no change, and among the option, which option? Think on it. As we know, if there is no change, that is no coloration take place. As we know, if a compound or if a D block element has completely filled D subcell, listen carefully, or empty D subcell, then they form colorless compound. As we know, ZnCdHg, Zn has 3D 10 configuration, completely filled. Most of the Zn compounds forms colorless compound. So we will check our option from Zn, that is the dichloride of metal. Now what will happen? Check it out whether we are correct or not. ZnCl2 plus KOH. Excess, first of all, what will give? It will give you ZnOH whole twice. Clear? If more OH minus ion, that is it gives you ZnOH whole 4 2 minus. Clear? What I'm telling? ZnOH whole 4 2 minus. It is a colorless solution. Am I right? Yes, sir, you are right. It is a colorless solution. Now look at the next again. The next one is, that is first time no change, that is a colorless solution, no change. Now I'm going to drop this part and we'll check the next one. What will happen? Check it out. Now that is test tube 2 ZnCl2. Now when treatment with dilute H2SO4, tell me what will happen. So it's very simple. It gives you ZnSO4, which is again a colorless component. Clear to you? So 2 is also correct. Now last chance. What to do? What will happen? Check it out. Test tube 3. I am taking ZnCl2. Clear? Now treatment with NH4 OH, that is NH3 plus H2O. It gives you ZnNH3 whole twice Cl2. What I'm telling? ZnNH3 whole twice CH2. Complex formation take place, or this is also a colorless compound. In other book it is also written like this, that is ZnNH3 whole twice 2 plus. This is a colorless form. So what we have taken, ZnCl2 satisfy the all condition. So it's better to minimize the option and put the best option from these all options. You will find the answer. So for this question, D is the correct option. So look at D. Clear, friend? Am I right? Yes, sir, you are absolutely right. Now move. Let's move to the next one. Now, question number 3. What will happen? Check it out. It's your turn. I'm giving you few seconds to think on it. This is one of the best question and most not most tough. It is most easy question. Now, tell me what will happen, friend. Okay, look at Cr, chromium react with NiBr2, then definitely chromium will displace Ni and Cd. That is, chromium is more reactive than Ni and Cd. Is confirmed? Now, but it does not, but it not react not with Zn. That is, definitely Zn is more reactive than chromium according to the first statement. So what is the order according to the first statement? Then first comes Zn, then comes Cr, then comes Ni, then comes Cd. Clear to you? This is the, according to the first statement, this is the order. Now Cd react with NiBr2. That is, definitely Cd is more reactive than Ni. Yes, sir. This is the second statement tells. But not with ZnBr2. Then definitely Cd is less reactive than Zn. Cd is less reactive than Cr. Am I right or wrong? Right. Here one more thing, this is not given here, completely not mentioned. ZnCr and Ni and Br. This is the Ni and Cd. Clear? Now, after including both the option, what we find here? First come Zn, then comes Cr, then come, look at Cd, then there comes Ni. Now, what is the order? Final order is Zn, Cr, Cd and Ni. So tell me which is the correct option here. Sir, it's very simple. The correct option is Zn, Cr, Cd and Ai. So for this question, A is the correct option. Clear, friend? So let's move to the next question. So friend, tell me what's going on these days. Are you enjoying or wasting your time? Tell me. What I am saying, live a healthy and strong life. Clear to you? Then and then only you can crack any competitive examination. Otherwise, it is not possible. Live happy, be happy and do the questions seriously. Clear, friend? So for this, what is the option? So now we can easily solve. That is, A is the correct option. Zn, Cr, Cd and Ni. Now friend, wait for a moment. Next question. Which of the following has been arranged in order to the increasing bond strength? As we know in Hg, if I talk here the Zn, Cd and Hg, that is the order Zn, Cd and Hg, and we know down the group definitely size increases. This is a simple thing. Due to the poor shielding of 4f electron, the bond strength of Hg is more than Zn and Zn2 2 plus and Cd2 2 plus. So what is the order in this case? Zn2 2 plus, Cd2 2 plus and Hg2 2 plus, because Hg here is only option which shows that it has more bond strength than Zn and Cd. So for this question, what is the correct option? Sir, it's very simple. For this question, C is the correct option. Am I right? Yes, sir, you are absolutely right. Now I'm going to rub this part and we'll move to the next question. Now what will happen? Check it out. Now, energy of which d orbital decreasing when MCN6, wait for a moment, let me once note down what is given here. MCN whole 6 3 minus, clear? That is definitely this is the octahedral complex, and if there is CN, then definitely hybridization will be D2sp3 is changed to MCN4. Okay, that's good. MCN4 minus, then what is given? A square complex, that is definitely DSP2 square planar complex. Now according to CFT, what will happen? Tell me. Sir, I am telling, wait for a moment. This is 1 2 3 4 and the final one is 5, that is the 5d orbital. Clear to you? Now this 5d orbital split like this. As we know, in presence of a ligand, we people know, I have discussed this thing in my lecture also. This one is dxy, dyz and dxz. Yes, sir. And this one is dx square minus y square and dz square. That is T2g and Eg. Simple in octa. But in tetrahedral, sorry, but in a square planar complex, what will happen? Tell me. The splitting is different from octahedral complex. What will happen? That is, first of all, there comes, look at, in dx square up plane is all okay, but dz square will come at lower plane. I have given the detailed explanation on this, remember. And what will happen next? Here comes dxy and the next one is dyz and dxz. So which one get less energy according when we compare this one? That is dz square and dxy, dxy, dyz and dxz. dz square, dxz and dyz. Here, which question is moving here? Decreasing. Decreasing, that is, in case of decreasing, which one is getting decreasing? That is, first one is dz square, dxz, and which one is increasing? That is dxy. Am I right? Yes, sir, you are absolutely right. This is a multiple choice type question. That is, for this question, there are three options: B, C and D. If you have any doubt, I am moving here again. Check it out what I am telling, listen carefully, compare this. dz square come lower, less energy, dx square come higher. I didn't show the complete splitting, just I have shown the simple figure so that you can easily understand. Clear? dx over above plane, then there come lower dyz and dxz. Clear to you? It can also be determined like this, that is, it come here, it will here. Like you can also write like this, then it will move upper side and this will move lower side. Now after comparing, you can easily compare this dx square minus y square. This one is dxy. This one is, tell me, sir, dz square. This one is dyz and this one is dxz. Look at what I'm telling. Which are getting less energy? dz square, dyz and dxz. So for this, we are correct. The three options are correct: yz, xz and dz square. I hope you can easily solve such kind of questions if you have a strong foundation related to the question. Wait for a moment. Give me a few seconds. Now let's move to the next section. Look at, this is one of the best question. Here we have to use few things. As we know, we are slight confusing. As we know, in tetrahedral the hybridization is either sp3 or if square planar complex dsp2. But here the hybridization is d3s. Though the structure is tetrahedral, but hybridization is D3S. What is the reason behind it? Let me explain. As I know, in case of COCl4 2 minus, definitely it has a hybridization sp3 and geometry tetrahedral. But in case of MnO4, they all these. Here the color for charge transfer. In this case, as we know, if I talk about Mn2 plus, the electronic configuration is 3d5, that is half filled, and the all oxygen present in it gives their electron. So the sensitivity of gaining those electron increases in case of D. That is, D will introduce itself during the acceptance of electron from oxygen atom. So there is no involvement of P, there is an involvement of D. D has more tendency to accepting. Due to this reason, though they have, what I'm telling, though they have tetrahedral geometry, but in case of MnO4 minus K2Cr or K2CrO4 2 minus K2CrO4 KMnO4 and K2Cr2O7, these are slight different. So in this case, be careful what I am telling. There is a, though they have geometry tetrahedral, but there is a not involvement of 3p, there is an involvement of 3d half filled. So easy tendency, what I'm telling, listen carefully, easy tendency to get the electron pair from oxygen, because as I told you earlier, they are colored compound due to the charge transfer, not DD transfer. So this is the similar case. What I am telling, listen carefully, this is the exceptional, this is a different case. In case of KMnO4, K2Cr2O, K2CrO4 and K2Cr2O7, though the structure geometry is tetrahedral, but hybridization is not sp3, there is no involvement of P, there is the involvement of D, D3S. This is one of the most BVVI question. Clear? And again I am repeating one more question related to this. Why they are colored? Due to charge transfer, due to not DD transition. Clear? Now I am going to wrap this part and we'll discuss the next one. Wait for a moment, friend. Give me few seconds. Now the next question is match the, now look at K2Cr2O7. As I told you, the color K2Cr2O7 is colored, P is correct. As we know, KMnO4 is also colored, then for KMnO4, P and color. As we know, this is Cu compound, Cu and Zn. Generally here Cu is in oxidation state, that is D10, 4s1 D10. For complete filling, it is a colorless. So for Q is the correct option. Now for TiS2O Hol 6 Cl3, Ti is in +3 oxidation state. What I'm telling, friend, Ti is in +3 oxidation state. So how to find the oxidation state? People know that X 0 into 6 is equal to +3 Ti. Clear to you? Clear, friend? That is the +3 oxidation state. And if it is in a +3 oxidation state, now what will happen? Tell me. It's your turn. Now it's your turn. Check it out. For first of all, now I'm going to discuss one by one. K2Cr2O7, first of all, colored due to charge transfer mechanism. Okay, that is P and T, and Cr2 plus, that is the diamagnetic in nature. That is, for this the option is P, T and S. Now for KMnO4, again it is colored due to charge transfer. For P, then charge transfer T and S. This is all are diamagnetic. Now there comes Cu and CS3 Hol 4. Now what will happen in this case? Tell me, friend. That is, tell what will happen. Whether it is colorless or colored compound? Think on it. Now I am leaving these things for you. Think on it. What will happen? That is P and S, colored and diamagnetic. Now for Ti, as I told you, Ti is in a +3 oxidation state, atomic number 22, that is 3D2 and 4S1. Clear to you? Wait for a moment. Ti 22 atomic number, 4S2, 3D2. If Ti is a +3 oxidation state, if it is a +3 oxidation state, then what will happen? Look at 3D1, 4S2. That is, Ti is in a +3 oxidation state, so it can be written a +3, that is 3D1. If there is a 1 electron, then definitely it is a paramagnetic. So if it is a paramagnetic R and that is 1 electron, that is colored. For this option, P and R is the correct option. For Cu, that is a +1 oxidation state, this is colorless. So for this, Q and S. Now the complete option: PTS, PTS, then QNS and PAR. Because here copper is in +1 oxidation state, +1, that is the 3D10, and 4S1, removal of electron, that is the 3D10. If 3D10, what will happen in this case? We people say completely filled. If there is a completely filled, then it is colorless. Completely filled, that is a diamagnetic. So Q and S for C option. For Ti +1 of 3D1, that is it is colored. P and 1 electron, that is paramagnetic, that is P and R. For K2Cr2O7, sir, is very simple, PST. For KMnO4, PST, because for K2Cr2O7, KMnO4, they all are ligand metal charge transfer, as I discussed in my previous question also. Clear? Check the things. I am giving you a few seconds, check it out. Clear? Now let's move to the next question. What I am telling, friend, listen carefully. Now look at what is given. Involve, that is what is the difference in the oxidation state of X and chromium. What is chromite ore? First of all, as we know, the chromite ore is FeO into Cr2O3. Definitely that is Fe Cr2O4. This is the chromite ore. Yes, sir, you are correct. Now, the next one is fused with Na2CO3. That is Fe. Wait for a moment. Look at Cr2O4. Treatment with Na2CO3. Clear? In presence of air, that is O. Then what will happen? Sir, is very simple. Na2. Clear to you? CrO4. Clear to you? When add Na2CrO4, when add water, that is, and filter, then it gives you, that is the solution, which on treatment with H2SO4, it will give you a solution. That solution is Na2Cr2O7. That is potassium dichromate, sodium dichromate. Clear? Again, let me check once. Chromite O. I'm moving here, friend. Chromite O. Chromite O is FeO into FeO into Cr2O3. Clear to you? Now, what will happen? It can be written like this: FeCr2O4. Clear to you? Now, in presence of Na2, it gives you Na2CrO4. Yes, sir. Solid mass, add water, then it gives a solution, and which on treatment with H2SO4, it gives you Na2CrO4, sodium dichromate. Okay, Na2Cr2O7. Clear? Now, what is the oxidation number, difference in oxidation number of chromium? In case of an FeCr2O4, what is the oxidation state? Check it out. +2, 2 into X plus -2 into 4 is equal to 0. Yes, sir. 8, 2X minus 6 is equal to 0. Yes, sir. X is equal to +6 upon 2. X is equal to is in +3 oxidation state. Yes. Now, in Na2Cr2O7, check it out. that is plus 1 into 2. Is it visible to you? Now, and 2x, that is minus 2 into 7 is equal to 0. 2x is equal to, what will happen, 2 and 12 is equal to 0. X is equal to 12 upon 2, that is equal to 6. What I am telling, that is equal to 6. Check it out once. Na2Cr2O7 plus 1 plus 2. Okay, Cr2x, 7 to the 14, that is 12 to x is equal to x is equal to 6. Now here is the contradictory. This is one of the best question. Now what is the oxidation number between chromium? Here according to plus 3 and here is plus 6. So the difference in oxidation number is 3. So the answer is, we people can say, so the answer is 3. But one more thing I am going to mention. Listen carefully. As we know, in chromium, the final electronic configuration, that is 3d5 4s1. Clear? This is the chromium. You can also write like this, 3d4 4s2. Clear to you? Check it out, 3d4 4s2. Now how much electron are there? 6. That is the complete oxidation state, that is plus 6, and in this case plus 3. Now we can say the difference is 3. So for this question, now we can easily explain what is the difference in oxidation number. That is, the difference is 3. Clear? For integer type question, 3 is the option. Now friend, I am going to rub this part and we'll discuss the next question. Wait for a moment, give me few seconds. Now the next question is, if order of size of lanthanide ion are in the order, clear to you, P3 plus, Q3 plus, R3 plus, S3, then P, Q, R and S R. Tell me what will happen in this case. I am giving you few seconds to think on it. So tell me what will happen. This is the lanthanide series. As we know, if we move from left to right, then the size decreases. So what is the case? This is A is the correct. This is a simple question. Clear? Now let's move to the next question. Now read the question carefully. This is one of the best question. On treatment with cold water, okay, element A reacted quietly, liberating colorless gas, okay, and solution C, lithium reacted with gas B, giving a solid product D, which gives effervescence with water to give basic solution. Definitely, when CO2 was passed through the solution C, an initial white PPT formed, but this redissolves, forming solution G. When more CO2 was passed, PPT effervescent when moistened with concentrated HCl and gave a deep red coloration to Bunsen flame. Okay, E on heating with excess of carbon gave H. Okay. Now metal may be, then definitely metal is highly reactive, that is the alkaline earth metal. All option are alkaline earth metals. Clear? Now what will happen? Let's check it out. If I write here metal, then treatment with cold water, okay, alkaline earth metal, that is plus 2 oxidation is clear. Now it gives you MOH halt twice and plus H2. Wait for a moment. MOH, this is the red A, and reacted colorless gas, that is definitely hydrogen, this is B, okay, and a solution, this is C, okay. Litmus reacted with B, that is H2. When reacted with litmus, then what will happen? Sir, it gives you lithium hydride. Yes sir, that is giving a solid product D. So this is the product D, okay, which gave effervescence with water to give basic solution, that is LiH plus H2O. Then what will happen? That is LiOH. That is the basic solution. As we know, alkali metal hydroxide are basic in nature. Clear to you? Now LiOH, wait for a moment, let me balance the reaction. 2 LiOH H2, that is 2 to 4. Here put 1 by 2. Now oxygen is 2 times, no, oxygen is 1 times. Put here, wait for a moment. What will happen? LiH plus H2O, that is lithium hydroxide, LiOH, lithium hydroxide. Then what will happen? Check it out. Then sir, is very simple, that is LiOH. Wait for a moment. LiOH, when treatment, when CO2 is passed through the solution, look for a moment, CO2 is passed through the solution, okay. See, an initial white PPT was formed, initial white PPT, and definitely it gives MCO3, and when more CO2 is included, then it gives you MHCO3 whole twice. Clear to you? Now the question comes here, white PPT, and as we know, white PPT is of calcium, so the metal M is calcium. Clear? Now what will happen then when moving here? Check it out. Forming solution G, wait for a moment, pass through the an initial white PPT, that is E, that is we can say E is CaCO3, okay, and was formed but did dissolve, forming a solution G, that is this is G. Yes sir, when more CO2 was passed, PPT E effervescent when moistened with concentrated HCl, that is E, when treatment with, that is M. Now we can say CaCO3 plus HCl, okay, that is it gives you CaCl2 plus H2O plus CO2, okay. Now E on hitting with excess of carbon, E on hitting with excess of carbon, it gives you H, and H is definitely calcium carbide. Clear to you? So what is A, B, C and D? Now listen carefully what I am telling. Now look at what I am telling. On treatment with cold water, that is A is, yes sir, calcium. Now B is H2, yes sir. Now C is CaOH whole twice, yes sir. Now D is LiH, yes sir. E is calcium carbonate, CaCO3. F is LiOH, lithium hydroxide. Now what will happen? Now G is, tell me what is G? So G is that is G is CaHCO3 whole twice, that is then after H is CaC2. These are the product. Clear? Now wait for a moment. Now read the question. Metal A may be calcium. So for question number 1, B is the correct option. Now solution G contains a salt. This one is salt, and it causes permanent hardness. Definitely not. It cannot be obtained in solid state. No, because dissolves. It causes temporary hardness. As we know, temporary hardness due to the calcium and magnesium bicarbonate. So B and C is the correct option. What is B and C? 2 and 3. C is the correct option. Clear? Now let's move. What will happen? Solid H. Solid H is calcium carbide. When treatment with AgNO3, then what will happen? It gives you normal reaction Ag2C2, and this Ag2C2 is white PPT. What I am telling, this Ag2C2 is white PPT. Wait for a moment, I am rubbing this part, and finally I am writing the overall reaction in this case. Clear? Now give me few seconds. Again I am writing, that is, now what is A? Now you can easily say, sir, A is calcium, Ca plus H2O. It gives you CaOH whole twice plus H2. Am I right? Yes sir. Count the number of hydrogen here. 2 hydrogen, 2 oxygen. Put here 2. That is CaOH whole twice plus H2. Now this is A, yes sir, this is C, and this is B. Clear? Now it gives product Li plus H2. Clear to you? It gives you 2LiH. This is D. Clear? Now when CO2 is passed through the solution, it gives you CaCO3. When excess H2O, it gives you CaHCO3 whole twice. This is E. Clear to you? And this is G. Now what will happen? Again, when LiH on treatment with H2O, it gives you LiOH. Clear to you? What is given here? LiOH. Now how to balance? If I put here 2, then that is it 2. Now hydrogen is 2 to 4. We have to put here again. If I write, this is F. Clear? Now if I put here 4, then what will happen? That is 4, then is 4L, LiOH. Clear to you? Now this is F. Now how to solve such things? A, B, C, D, E, F and Z. Finally this is the correct explanation. Now check it out. Do you have any doubt related to this? Then I am always here to serve you. Check it out, friend. That is A, CaOH whole twice, B, then H2, then LiH, then with water aqueous solution, that is LiOH. Clear to you? Now tell me what will happen. Check it out. That is LiOH, then CaCO3, CaHCO3 whole twice, CaOH whole twice with CO2, that it gives you CaCO3. Clear, friend? If you have any doubt, then you can easily approach to me. Here also a release of hydrogen also take place if there is a excess of H2O. Now this is the complete solution. Clear? If doubt, then tell me. I am waiting for you because it is one of the best question. Check it out. Check the things very carefully. If doubt, then come here. Okay. Now, friend, I am going to rub this part and we'll discuss the next one. So this is the last question. Now review the question. What will happen? That is, for question number 1, D is the correct option. For question number 2, D is the correct option. For question number 3, tell me A is the correct option. For question number 4, C is the correct option. For question number 5, multiple choice question, B, C, D is the correct option. For question number 6, B, C, D is the correct option. For question number 7, for A, P, S, T. For B, P, S, T. For C, tell me that is Q and S. For D, that is P and R. Clear? Now for this question, difference is 3. Now for this question, A is the correct option. I have given the detailed solution in this question. I think now you can easily solve such questions. Clear? So friend, time to say bye-bye. Thank you so much. We will meet again.